Good morning or good afternoon, everyone, depending on where you're joining us from, and welcome to today's webinar. My name is Harminder Singh, and I'll be hosting this webinar today. It's our pleasure to have Jenbacher with us today, who will be presenting this webinar titled Future-Proofing Your Energy Supply, Navigating On-Site Power Generation Solutions for Data Centers. I'll now provide some housekeeping information before we start. First of all, please send your questions throughout the webinar by putting them in the Q&A box. Please don't wait until the end. We'll allocate some time at the end of the session to address any questions or thoughts that you may have. If any of your questions do not get answered today, these will be available to be answered later. For any related content on the webinar, please click on the widget shown on your screen. And in case you have any technical issues, please click on the help icon. With this, we'll now begin our presentation. So I'll be taking the first section, which will be on global power trends and data centers. But before I do that, I'll introduce today's speakers to you. My name is Harminder Singh. As I mentioned, I'm the Director for Power at GlobalData. I manage research and analysis for power sector and responsible for the company's Power Intelligence Center. I specialize in research in power, renewable energy, and smart grid sectors. Have more than 20 years of experience, most of which has been in energy sector research. The next speaker is going to be Marcus Stromich Yenevine, who is the Director for Commercial Strategy and Business Development at INNIO Group's Jenbacher Solutions. Marcus is responsible for developing and implementing the commercial strategy for INNIO Group's Jenbacher brand, including H2 engine platforms. As a seasoned sales professional, he focuses on identifying and capitalizing on opportunities in the global energy landscape, particularly in decentralized hydrogen-based energy solutions. Marcus also serves on INNIO Group's sustainability board and has been with the organization since 2007. He holds a master's degree in international business from the University of Applied Sciences in Graz, Austria. Thomas Sieber is the Director for Data Center Power Generation at INNIO Group's Jenbacher Solutions. Thomas holds an electrical engineering degree, a bachelor's in management and economics, and a master's in international business. In his previous roles, Thomas served as global warranty leader for Jenbacher gas engines, service product manager for GE Distributed Power's Type 6 engine platform before he decided 7 years ago to join the global sales organization of INNIO Group, where he currently is director of global technical sales for the Jenbacher brand. With this, I will now start the presentation. So this slide basically looks at how the power demand in the US is forecast. So the charts that you are seeing here show you the the peak demand growth for 10 years, as well as the net energy for load growth for 10 years, and how the forecasts have been changing over the years. So the last bar that you see is the forecast that was made in 2024 for peak demand, as well as for net energy for load growth for the next 10 years. So you can see, there is a significant increase that we are seeing in the forecast, both for peak demand as well as for load growth. And since 2022, the growth rates have been rising very, very sharply, and it's reversed a 2-decade trend of falling or flat growth rates. So if you look at the numbers very quickly, just the last 3 years, maybe we can see the kind of growth that we are seeing here. So 2023 to 2032, the forecasted growth was about 62 gigawatt. Then it rose to 92 gigawatt of the next year, and then the forecast for 2025 to 2034, the growth during this period is expected to be about 150 gigawatt or so. So you can see the kind of growth we are experiencing. Similarly, in case of the net energy in gigawatt hour terms also, you can see the kind of growth. And the reasons for this growth are, we are seeing increased amount of large commercial and industrial loads connecting to the grid. There are emerging large loads such as data centers, including crypto and AI, and also hydrogen fuel plants. So these are the kind of loads that are getting connected to the grid, and they are presenting unique challenges for forecasting and planning for the increased demand. Moving forward, this slide shows you the data center projects in different stages of construction in the US. So as global data, which is tracking the data center projects, around 500 data center projects, including investment of around $540 billion, are in various stages of construction in the US. And these new data centers, which have the potential to consume enormous amounts of power and they can be built relatively quickly, they are driving much of the explosive demand growth that we are seeing. Apart from this, there are other factors like electrification in various sectors, other large and commercial industrial loads, such as new manufacturing facilities, and also hydrogen fuel plants that are factoring into the higher demand forecasts. And this is leading to new uncertainties in forecasting, whether it's for peak demand or for hourly load. For example, data centers, as we know, they have longer operating hours than most other loads, and they require more heating and cooling than any other commercial buildings. Just as an example, in Texas, crypto mining facilities that have been connected to the grid in recent years, they scale their operations and hence their electricity demand depending on the electricity prices. So this shows how much fluctuation it can bring to the grid. The behavior of large data centers during normal grid faults is also a cause of concern because of the customer initiated automated disconnecting of load can cause operating issues into the grid. With all these challenges that we are seeing, on one hand, as you can see, there are large loads getting connected to the grid. On the other hand, what we are seeing is that the growth in the grid is not in line with these new demand centers that are coming online. So if we compare the generation and storage capacity that's being added, and again talking about the US, but it would hold true for other countries as well. So we are seeing large growths in both generation as well as energy storage capacity. However, the rate of growth in transmission capacity is not in line with the growth in generation that we are seeing. If we look at the US, the average grid interconnection timeline for new generation projects has increased to 5 or more years from an average of 4 years some time back. Close to 2,600 gigawatt of generation and storage capacity is still in interconnection queues, and the cost is also rising. So average interconnection costs has also risen quite a bit. There are also constraints that we are seeing in different areas, be it Mid-Atlantic region, be it parts of New England and Southeast region. So there are a lot of grid constraints, and the grid is not able to accept new supply. So there will be limited ability for these regions to discharge new electricity to consumers, till the period 2027 to 2028. There are siting and permitting challenges that are hampering transmission development in many of these regions. Also, if you look at the projects of the close to 1100 plus projects that are under construction or in planning for the next 10 years, over 110 projects are currently delayed from their expected in-service date. So what we are seeing is that the grid is not coming up in line with generation. Now, hence, what data center operators need to do is to look at alternative sources of supply, and that's what we are seeing happening. So if you look at all the big players, be it Microsoft, be it Oracle, Amazon, or Google, all of them are looking at alternative ways of meeting their requirements, and small modular reactors are coming out to be a very promising technology in order to meet their needs. If you look at what different companies have been doing, Microsoft is looking at SMR technology very closely. They have signed a PPA with 3 Mile Island Nuclear Power Plant, which is currently not operating, but subject to regulatory approvals, it could restart. Oracle has announced that it will build a gigawatt scale data center powered by 3 SMRs. Amazon again is signing PPAs. They've signed 3 agreements with Energy Northwest, X Energy, and Dominion for SMR development. And Google again has signed an agreement with Kairos Power to deploy advanced nuclear power projects totaling 500 megawatt. So we are seeing a lot of traction and interest from these companies for SMRs. However, we have not really seen any SMR projects becoming operational. And looking at the history of nuclear power plants, where there have been cost escalations, there have been time escalations. So it still remains to be seen how that's going to pan out. But definitely, this is a very good technology for data center players, because it can provide base load power without the issues of intermittency, and still being a clean mode of power generation. There are other strategies as well that companies are employing to meet their data center needs. If you look at the kind of the kind of impact data centers are going to have for the US, data shows that the data centers will are expected to account for almost 9% of the total electricity demand by 2030. There are around 470 projects in the US, followed by China with about 140, India with another 120 plus projects. The size of the data center market is huge, expected to be about $160 billion plus by 2028. We are also seeing PPAs being signed by many of the major players, be it Amazon, Microsoft, Google, Meta, Apple. They are all signing different PPAs with renewable energy players in order to purchase electricity directly from the generating companies in order to power their data centers. So these are some recent examples. Google signing a 12-year PPA from a 435 megawatt power plant by Energy RE. Microsoft has signed a PPA with Statkraft, Energia Group, and Power Capital Renewable Energy, totaling around 900 megawatt to cover data center operations in Ireland. So these are just some examples. There are many other PPAs that have been signed, which is not possible to show here. But that was my part of the presentation. I'll now hand over to Marcus to take over from here.
Harminder, thank you very much for these very in-depth details, mainly focusing on the US market. But let me introduce, first of all, our company to you and why we are here. But before I do so, let me recap some of the arguments we have heard from Harminder. So we see there's a definite rising need for reliable power, right? Challenges are aging power grid, high emissions from diesel generators. This is a special focus of this data center industry at the moment. We see definitely, and this is not just limited to the US, a lack of new grid connections and the length of getting those grid connections realized, which is taking up to 5-6 years and even more in some of regions of the world. And we see there's a shift towards better performance, higher efficiency, less fuel costs, and this is gaining more and more importance and momentum. And due to the rising need of power and the huge demand of certain industries, especially the data center industry in reliable power, there's as well a challenge with regards to lead time of technology. We will go later on in our presentation into all of those details and explaining you why we are holding this webinar today. In order to overcome the challenges, there are certain trends in the data center industry. So many think about bringing their own power. Many of those co-location and hyperscalers are really thinking and have sustainability goals set in their targets to replace diesel generators with low emission technology like natural gas generators, not just for emergency backup power, but even for other use cases like continuous operation. There are several and many different reasons to do so, and we will later on explain you why those reasons are existing and how we overcome and help this industry to grow in a speed which they need to grow and have their expectations. Before I do so, let me show you in the nutshell why we are talking about this technology. So today you have a very general, sophisticated, concentrated power plant infrastructure in many of the countries. You have a stable grid so far and diesel backup power, which is installed at the data center. But now those data centers need to grow, they need to expand, they want to be part of the AI trend and introduce AI technology. This needs more data centers and this needs more power. And the trend for tomorrow is definitely having a focus on renewable energy and a very sustainable way to provide backup power, bridging power, and have this installation future-proof for full carbon zero net carbon technology. Now we are going into more details, and that's why I need to tell you why INNIO and why Jenbacher is playing a role in this game. And this is just one of many illustrated pictures, but we will show you later on some real examples. So stay with us in the next couple of minutes, and we go into more details. But for those who have never heard about Jenbacher or INNIO, we are an energy solution and service provider active in many different applications, active worldwide, and we are part of the INNIO group. The INNIO group comprises two major brands. It's first of all the Jenbacher brand, which we will talk about today, but as well the Waukesha brand, which is specifically well known in the oil and gas and compression business based in the US. Our factory, which you see here on the picture, is based in Austria. We are placed in the middle of the Alps in the beautiful area of Jenbach, which is also the town where the factory originates from. From a perspective of supplier, we have installed now more than 37 gigawatts. We are actually close to 40 gigawatts of installed power capacity worldwide. And we provide different power generation equipment in different sizes to suit as well all the different applications we are playing in. This is from renewable gas applications to natural gas applications to special gas applications, all concentrating about high efficiency, reliable power generation, most of it in a combined heat and power mode to be as efficient as possible. Therefore, we have developed over the years different platforms, and all those platforms have their positive advantages in the certain segments. They are in the size of 250 kilowatt to up to 10 megawatt per unit electrical power output. And you can expect here all of our equipment is as well available in a combined heat and power mode, which means we focus on the utilization of the highest efficiency out of these engines and can provide heating or cooling as well in addition to electricity. In order to install our equipment in the most efficient way, there's a certain trend towards fully packaged and containerized units, and for sure we can provide those fully packaged kind of turnkey packages, which are very well suited as well for the data center application. Later on, my colleague Thomas will tell you more about this modular installation concept, which is first of all very reliable because it's pre-tested, it's pre-engineered, it's pre-assembled, so we minimize the construction site or the construction works on site. And the modular system comes with a lot of advantages when it comes to resiliency to the data center business. The reason why we talk today about gas engines is clearly that engine technology has improved tremendously over the last years. And this engine technology provides a lot of advantages which fit very well to the future and the renewable energy scenario of our energy landscape. So this is a picture which shows the general advantage of a modular power plant with a multi-engine installation, and when it comes to part load efficiency compared to, let's say, a simple cycle gas turbine. This efficiency play is more important now in times of high renewable power on the grid when it comes to peaking applications of modern power plants. So it doesn't matter whether you run the power plant at 10% part load factor or at the 90% part load factor. We always ensure with our technology that we can run at the highest possible efficiency point, regardless of the part load factor of the power plant. And this modularity is as well one of the reasons why the technology fits very well to the data center concept, because here we see as well a modular approach, a modular integration of our units into the data center energy infrastructure. So a modular approach does not always mean it's a higher service effort for the equipment, because an identical configuration in some extent also minimizes the service effort. So it's really a copy-paste approach on site. Operator, service team know what to do. So from this perspective, it provides the highest efficiency and the highest reliability possible for a power plant. Our technology also comes with a quite sophisticated two-stage turbocharger design. And this design allows that we, as a technology for power generation, can run at very high ambient temperatures without very costly active air inlet cooling infrastructure, or even a very costly derating in efficiency, because then we would have higher fuel consumption, or we have a derating on the power. This technology allows, with this special turbocharger system, to run at the highest ambient temperatures possible in the market, and it provides as well an advantage if the technology is installed at the high elevation, where the air the air demand is getting higher, and turbocharging technology supporting here to as well avoid derating. So depending on the site conditions, our technology as well plays a very strong technology role and can outbeat other technologies with regards to its performance. Last but not least, fuel flexibility. I mentioned it before. We are concentrating very much to utilize our engines in the future with renewable fuels. Those could be hydrogen, those could be ammonia, or what the markets are then finally producing. We are uncertain about that one, but we are certain that our engines are already today hydrogen ready, which means it's a future-proof technology, and our clients bet on our technology that they can fully decarbonize their energy system in the future once the respective renewable fuel is available. And very important argument for the gas and the engine technology in general is as well water consumption. Our engines are cooled with water, but in a closed water circuit. This means those engines not have any continuous water consumption. We don't need water in order to bring down, for example, air inlet cooling, because the formerly explained technology advantage on two-stage turbocharging, for example. We don't need the water to bring down the emissions, because we already have very low emissions. So from this perspective, water consumption is gaining more importance as well, because many of those plants are installed in very high ambient temperature regions, where typically water scarcity is as well a very important topic. So in a nutshell, we have a lot of advantages against other technologies. We have a very high simple cycle efficiency of up to 47%. We have a very favorable starting time, so we can really duplicate diesel engine performance with our gas engine technology. We can have unlimited starts, operate at lowest gas pressures. The CapEx and OpEx is definitely very interesting for our technology if you compare it one-to-one to other technologies. And it's an investment security, which we bring on the table, because we can run on future-proof fuels like hydrogen. We have standardized components, and our multi-engine concept on site provides a lot of flexibility for future growth and for resiliency as well. So with that, I wanted to focus now on the more important topic of today's discussion, and I'm happy to hand it over to Thomas.
Thank you, Markus. And I think, a good summary already what we have heard first from the market as well on our solution. What I have the pleasure now is, I have the pleasure to share with you some examples, what we have delivered already, or what we have in execution, and why we have been so successful in the data center industry, and how we can bring value to the industry by either our sustainability mission and as well helping to power the industry where is currently lacking a little bit of grid connections. So when I start with that, I normally always introduce, okay, what options do we have out there, right? And what options do we have out there, right, in terms of decarbonization? So there have been a lot of talks about hydrogen in the past, right? I would say several countries who have more focus on hydrogen. Some other countries have not that much focus on hydrogen. In general, at the end, it doesn't matter, right? If it's hydrogen or any other renewable fuel, how to help to decarbonize the industry. Hydrogen is just a renewable fuel, but there are other renewable fuels. And what is very important is that, for example, most of our clients even don't know that we have more than 50% of our fleet is running on decarbonized fuels already, because we have so many biogas installations, biomethane installation, or any other renewable fuels which are already running in our units since several years. So we are in the industry since decades, and therefore what Markus mentioned before, 40 gigawatt of installed power already, yeah, 50% out of that nearly is already with decarbonized fuels. So we are doing that already. So this is not something new for us, but we're going to hear about that. And what we see as first movers, because if we really talk about hydrogen a little bit more, hydrogen is the new gold, as it has been over the last years. And therefore, the first movers are most of the time only those ones who are not really using hydrogen that often. So therefore, we have had some experience, and we've made some experience, especially with the data center industry, from moving from diesel backup generation directly to hydrogen backup generation. I'm going to have a use case about that just a little bit later. We are seeing a lot of microgrid applications. Microgrid means that we are assembling the best of available technologies out there to have 100% reliable power. So that means microgrids, we are bringing together solar power, wind power, we're bringing battery energy storage system together, and as well peaking those intermediate times where the renewables are not available, potentially with hydrogen-fueled gas generation units from us. We are seeing a lot of demand in terms of balancing. Balancing means capacity, grid balancing. A lot of the developed grids out in the market are seeing the challenges that they need to be able to supply the power to 100% demand. So therefore, we see capacity markets growing in countries where there haven't been any capacity markets. We have a huge fleet alone in the United Kingdom, where a lot of our units are only utilized for 500 to 1,000 hours per year, just to stabilize the grid and ensure that the consumers at the end, which are all of us, are getting the power which they need, and we're not lacking a grid outage. Then we see as well flexible combined heat and power applications. Flexible, what does that district heating net? All of that use that's the minimum.
Sorry, it seems we have a short connection problem here. We will refresh and reconnect within some seconds. Try again, Thomas.
I should be back. Sorry for that. I'm back in here. So good. I just give a summary of that slide again, because I think some of the things might be obvious. So recap: first mover hydrogen for data centers backup generation, but as well a use for renewable fuels as well in balancing markets like in the UK. And especially those first movers have been in the data center industry because they haven't been really using the hydrogen in that magnitude, because for the backup installation, you would be burning gold at the moment because the hydrogen prices are pretty high. And with that, let me move already to the first use case, which is a 200 megawatt plant used in installed in Germany, in the north of Germany. It's a combined heat and power plant. This is not a data center application, but what we want to show with that is that the industry is already committing to decarbonize our units, and therefore we have solutions available which we can bring then as well to the market, and which we have brought to the market already for running all our engines on hydrogen. The concept of the 200 megawatt plant is really generating power in peak demands, and as well at the same time generating up to 200 megawatt of heat in the district heating network for the local district heating industrial users in that area. And with that, we are already reducing 70% of the emissions, which is roughly 1 million tons of CO2, which are cut with a move from a coal-fired plant to a combined heat and power plant. In general, we talk about roughly 75,000 households which are secured with affordable power. And the target of the client is that he wants to be totally decarbonized by moving as hydrogen to a fuel by 2035. So 10 years down the road, he has a line of sight that he is going to have fully decarbonized as well the existing plant and has fully moved out of coal and natural gas. So at the end, this should give you this awareness that that natural gas is seen as a bridging technology, and we're going to see that as well in one of the other examples. If we look into the next example, which is a pretty small project compared to before we talked about a 200 megawatt project, but here we're talking about only half a megawatt. But what is very interesting in that application, which is a small town in Austria, in Kampan, it is the first one megawatt class hydrogen powered combined heat and power plant in Europe. And very interesting on that use case is that the client, which is the RAG Austria, they are generating the hydrogen by themselves with on-site electrolysis. The electrolysis is fueled by renewable power, owned by them as well. Then they use underground natural gas caverns, which they normally have used in the past to store natural gas, as it said. And then they are pumping the hydrogen produced in the summertime into the underground natural gas caverns. And the underground natural gas caverns are then used to store hydrogen as an energy till the winter time, because in winter time the sun is not shining that often, right? So therefore they're using in the winter time the stored power in hydrogen and pump it out of the underground cavern again, and then with our equipment they are going to produce power and heat for the local community. So at the end, it's a totally decarbonized solution where they make use of hydrogen as a storage capacity instead of a battery energy storage system, because the battery you cannot store long duration. You cannot store power in a long duration for a longer duration than several hours, and therefore hydrogen is, let's say, a perfect vehicle as well to transfer power from summer to the winter. If we then look on the next case, this is then giving you, let's say, an overview why this transition is going to happen over time. So we have heard before coal or diesel as a fuel source. By moving to natural gas, we're already reducing 70% in CO2 emissions. And then when moving to hydrogen, whenever it's available, we are fully decarbonizing it. But very interesting as well is, if we now talk about the hydrogen, if you now talk about the data center industry, by moving out of diesel to natural gas, we are removing 90 to 95% of the NOx emissions. And as we all know, who are familiar with the data center industry, NOx emissions are the one criteria for getting permits on. So that means we are helping the industry as well to get out of the nitrogen oxide emissions, which are very relevant, especially for backup generation, but as well for continuous power supplies are of essence. But if you talk about continuous power supply to a data center as well, we need to look on other emission limits as well. The good thing is natural gas, and with the, let's say, emission reduction systems available, which we have, we can in principle fulfill any regulation globally and being able to run our units 24/7 for continuous power supply.
Sorry, Thomas, while you are transitioning, I would like to request the audience and remind them once again that in case you have questions, please feel free to put them in the Q&A box. Yeah. Sorry, Thomas, please continue.
Thank you, Harminder. Now, first use case of a backup power solution on hydrogen. So we have been asked Yeah, this is 2 years ago, more than 2 years ago. We have been asked by a client, which is called North Sea, if we can help him to decarbonize his backup power generation solution. So he traditionally has used diesel generators for his backup solution, but as well has tried out some fuel cells. That was then the fuel cell test was then in 2022. After that, he has not been happy with the success of the fuel cell in terms of startup time and as well about performance and as well not about the economics in terms of capex and opex costs. So we have teamed up with him, and for his next data center then in Eindhoven, he has decided to go with 6 1 megawatt dual gas units from us. What does good dual gas mean? Dual gas means that the unit can run on 2 fuels. We have set up the unit that way that the unit can either run on hydrogen or can either run on natural gas. The primary fuel source is hydrogen, and the secondary fuel source is natural gas. So what that means that the unit is going to start on 100% hydrogen, and as the client does not have any hydrogen pipeline at the site, he's storing up to 2 hours of hydrogen at the site. And as the supply chain of hydrogen is not yet that enhanced that he can for 100% ensure that in case of a grid outage, when he fires on his backup generation solution, that he will be able to refill his on-site tanks. And in case he's not able to refill his on-site hydrogen storage tanks, he can transition while the engine is running from hydrogen operation, from 100% hydrogen operation to 100% natural gas operation. So this gives him the resilience, even in the case of the weak point of the hydrogen infrastructure, that he can always ensure 100% reliability of the power. At the site, the client is expecting to have sooner or later as well a hydrogen pipeline that he can run the backup solution solely on hydrogen. But for the moment, he still has this secondary fuel as a plan B in case he's not able to refill the on-site storage tanks. Then we have one of our first installations. So that's 7 years back, roughly. That's how we have started, where we have introduced first our units to a hyperscale installation in the US, in Wyoming. It's a 60 megawatt installation where no diesel generators have been placed at site. And the main reason why we have been chosen is because we have the same start time and same start performance like a diesel generator, but with a lean burn gas engine at 3 megawatt. This is a kind of a unique setup with the same footprint, and therefore have been main decision points for the client. Once again, unlimited operating hours, because he can take the data center as well off the grid if required. So he has in parallel as well some agreements with the local utility that he might need to load curtail, and the data center needs to get off the grid for certain peak times. And secondly, far lower emissions, 90 to 95% lower emissions compared to diesel backup solution. And as well as a third point, same footprint like a diesel generator and same integration like he has done it with a diesel generator. So there was no need to change any UPS system or add another battery storage capacity, as we have replicated the same start time. As well, we're going to extend sooner or later the plant with some more megawatts over the time. Very interesting as well, and this is what Markus already mentioned before, this site is at very high elevation and high ambient temperature, and we are not having any derate. And this is very unique for gas engines compared to example turbines technology. Another example is a project in Europe, in Ireland, in one of the data center hubs in Dublin. It's as well a 60 megawatt installation, again 3 megawatt generators each. Power is going to be delivered within 15 seconds. Very interesting here, the client is using our units for primary power and for backup power. Primary power, not in the essence that he has no grid connection at all, but he has a limited grid connection. What does that mean? Limited grid connection is that if he needs to withdraw a certain power from the grid, which is over a certain threshold, the utility cannot confirm that he's going to get it at that point in time. So therefore, he has to either use the on-site power generation plant to be able to power his data center, or what he can do as well, he in principle can do load shifting as well. His preferred way in general is to run the on-site power generation plant, because then he gets the best benefit of it. As well, there are no diesel generators at site once again. So that means that in case of a grid outage as well, all units are going to be fired up, and all units are going to deliver the power and a primary source to the data center. Everything in prefabricated plug-and-play solutions, in containerized packages, as has been explained by Markus as well. Then another use case, this is now not a containerized package, this is now really a so-called powerhouse in a cement building in terms of optimizing the power density of the complete installation. So it's 22 4.5 megawatt units which we have installed there, and the very interesting is it's 100 megawatt including the step-up transformers which are on the roof as well, in below 1 acre. So in below 4,000 square meter we can build a 100 megawatt power plant, and this is kind of unique power density, so we are not consuming a lot of land, and with that solution we are moving to 46-47% electrical efficiency. It's all simple cycle efficiency. There is no need to add any steam turbines for combined cycles. So this is really simple cycle technology, and the plant has been delivered in that way, including the billing within 14 to 15 months. So 15 to 14 months after order, after signature from the client, the complete plant has been delivered from our partner and from us in that time frame, and has been, let's say, kind of unique as well, especially in Ireland and as well in Europe. Then I'm moving to the end of my summary, and then I'm going to end it up then as well with opening for questions. So this is one of our just recent installations as well, together with a partner from us. It's during installation, therefore you're going to see that there's still some areas where you may see some people or I see some workbenches. So just out of the last, this is I think 2 weeks ago, it's going to end up as a 120 megawatt on-site bridging power solution with 43 megawatt gas generators. The idea of that plant is that the client is not going to see a grid connection till 2030 plus. Exact timing is not clear at this point in time, but we are offering with that solution together with our partner as well a solution that the client can build the data center already now and doesn't need to wait for the grid connection. So this is the only enabler at the moment in certain areas, being able to have a power supply to a data center, which is an on-site power generation plant. This can be as well integrated into a microgrid. In addition, what is very interesting, due to our favorable start time and excellent load change behavior, we normally do not need to add any battery storage systems. So therefore, we can handle that without them. Even for heavy changing loads, if you move into AI applications. As well, the catalyst is integrated. Everything is emission compliant to be able to run 24/7, 8,760 hours per year. The plant is in Texas. So in Texas, we all know that in certain areas of Texas, it can get very hot. So what is very important, again, to remind you that we can have, let's say, temperatures in the range of 45 degrees C or as well 110 Fahrenheit, or even more than 110 Fahrenheit ambient temperatures, that we are not going to start derate and can always ensure 100% reliable power of the rated power output of the unit, and not start to derate or maybe need to add some, let's say, air intake cooling, which some other technologies might need to have. And with that, I think, Harminder, I'm just handing it over back to you, because we are opening for the Q&A. And thanks for listening to us. And sorry once again for this short interruption after, let's say, 20-30 minutes where we had a little bit of a bad connection.
Thank you very much, Thomas. And thank you, Markus, as well for the presentation. We'll now open the house for Q&A. So just a reminder to everyone, please submit your questions in the Ask a Question box. I will start with a few questions that are already there. So the first question is that given the critical need for reliability, doesn't it make more sense to have highly dependable on-site power solutions similar to the firm energy microgrid systems that companies like VoltaGrid provide? It has a smaller footprint than solar and wind as well. So Marcus or Thomas, any of you would want to respond to that?
I think that's a perfect summary of our use case, right? Is exactly that. It's critical need for reliability. It is proven technology, and I cannot say more yes to that question that it is, right? Because that's exactly what we can deliver with our units. Is like we can be part of a microgrid system, and delivering that like there are companies out there who offering that as an energy as a service, as well in, let's say, in US dollar per kW basis, which is not that capex investment for the clients. So, but as well can be moved to OPEX. But 100% agree, that's the future, right? If a data center wants to be built now in grid constrained areas, there needs to be other ways. And these other ways is that we have seen a lot of site selection teams of the data center really moving into developing sites where they have a gas connection available already, because that's an enabler then at the same time to build up an on-site generation plant. But as well, there's possibility as well to truck in compressed natural gas. But this depends on the size of the data center and the size of the power demand. If that is possible and economically, most preferable is always to look for a location where a natural gas connection is available already.
Thanks, Thomas. Next question is whether all engines from Jenbacher are ready to run on hydrogen in the future or not.
Maybe I take this one. So as Thomas explained, and as we presented to the audience today, we have already platforms which are today available to run at 100% hydrogen, right? There were some, let's say, strategic reasons why we started with a platform from 600 kilowatt electric to 1 megawatt output running on pure hydrogen. And this is more or less a realistic go-to-market approach that we can also ensure our clients will have the amount of hydrogen available. As per today, and many of you from the energy industry may know, some of the major hydrogen production projects have been postponed. Green hydrogen is not available yet within the needed amount, right? From the perspective of concentrating on our own technology and bringing our technology to hydrogen readiness, we are in process of installing our own electrolyzers at the factory in order to produce our own green hydrogen. And with that, we will go on and continue to even bring the biggest engines we have in the fleet towards 100% hydrogen readiness. And as Thomas mentioned, some of the major municipalities in Germany who are running and have invested in our even 10 megawatt platform have already signed MOUs with us to bring their power plants into full hydrogen readiness within, let's say, the next 5 to 10 years. Again, this depends as well on the infrastructure readiness within Germany with regards to availability of hydrogen pipelines, hydrogen supply in order to really do the conversion. But what we can ensure, I think, to the audience here is that we will be ready, I think, much earlier than the hydrogen will be available in all the regions, because we are already that far ahead of having tested our major platforms on the pure hydrogen operation. And by end of this year, we will even have a serialized product on one of the major platforms, which are now gaining momentum and attraction in the data center industry. So I think in a nutshell, to summarize, our engines will definitely be ready for hydrogen. The path is there, the development is ongoing, and market readiness will be ensured within the next years.
Thanks, Marcus. The next question is that are Jenbacher engines ready for heavy load changes due to artificial intelligence data centers?
Yes, I gave a brief hint about that during the presentation at the end, and that is one of the reasons why we have been successful over time is because we have learned together with the industry over the last 7 to 8 years what is required in terms of frequency stability and voltage stability, and in terms of start time. If we talk about heavy load changes for AI loads, yeah, it's always a challenge because there is no one definition what an AI load is going to look like. There might be some assumptions, there might be some real life cases. The good thing is we are teaming up with companies in the industry that we are aware in which direction this is going to develop. We are having on our test bench regular tests here at the factory to ensure that we have products who can fulfill that. And the good thing is what we can is if you assume a diesel generator performance is good enough for a heavy AI load change, our units can do it as well, because we've replicated the same load change behavior on a natural gas unit compared to a diesel generator unit. And that is normally not what the industry has faced, because if we look back 2-3 years, all major gas engine OEMs have had start times of maybe around 5 minutes. We're talking about start times about 15 seconds, 10 seconds. So therefore, we have moved the needle far beyond and have been preparing for that, and have invested a lot in our products to be really able to deliver the frequency and voltage stability, let's call it the power quality, in that manner that the data center doesn't need to really bother about that if he's drawing the power from the grid or if he's drawing the power from an on-site generation plant.
Thank you, Thomas. We have time for a couple of more questions. So in case any of you have any questions, please feel free to include them in the Q&A box. Meanwhile, I'll just read through the next question. The next question is that there is a lot of talk that fuel cells might be a solution for data center power supply. So why should a customer choose gas engines over a fuel cell?
Maybe Markus, I take that. Fuel cells. So in principle, fuel cells are very interesting technology. There are mainly two kinds of fuel cells which the industry is looking at: SOFC fuel cell and as well the PEM fuel cell. SOFC fuel cells have a very high electrical efficiency. So we're talking the range of 55 to 60% electrical efficiency, which is very interesting from an fuel consumption perspective. But the only challenge with it is fuel cells are not really at the proven stage, right? There might be some opportunities going forward, and we have seen as well some first installations as well. One of our clients has used a fuel cell before he has moved to our unit, but at the end he hasn't been so happy with it so far. So it maybe the fuel cell technology is not yet ready at scale. Economics of scale might change that, but if we just talk about the LSOE costs or return on investment, as the fuel cells are so expensive at the moment and need as well, let's say, a decent amount of space and need to be stacked, it's not the preferred solution at the moment. And if we have been asked by the clients a lot, and when we're discussing about projects, we're very open about that and say, yes, fuel cell is a very interesting technology, but if we think about it and calculate it through from an economical and financial perspective, the return on investment of a fuel cell is 15-20 years out, because capex wise we are talking 3 to 4, sometimes even 5 times higher compared to a on-site power generation plant, even though the efficiency might be higher, but there we see a lot of derating as well over the years of the efficiency, and therefore it might take some more years, but looks like as well a promising technology, but maybe in 5, 6, 7, 8 years when we really have it as economics of scale.
Thank you, Thomas, once again. I think with that, there are no other questions. We have answered all the questions in the Q&A box. So thank you very much, everyone. And you can still send any questions while watching on demand. All unanswered questions and future questions sent will be answered at a later date. I would like to thank Thomas Sieber and Markus Reumich-Jennewein for this presentation, and Jenbacher for sponsoring the webinar. To the attendees, you will return an email with a link to the on-demand version of this webinar, or you can access this through our website, which is www.innio.com. arena-international.com. We look forward to sharing further webinars with you, so please do keep an eye on the website just mentioned. Thank you once again, and I hope you all have a nice day.
Thank you.